So welcome to this edition of Seen and Solved. I'm your host, Tim Pennington. And today we're talking to a true celebrity in the world of cleaning, Mike Valenti, Hubbard-Hall's Director of Technology. You don't consider yourself a celebrity, Mike? No? Okay.
No.
Well, you're the go-to guy. I mean, that's obvious. I hear from a lot of people. I've seen you speak, I think, dozens of times. You're out there. I know you've got a couple talks coming up, but you're a true expert in the field.
I try to be.
Okay.
You're listening to the Seen and Solved podcast, brought to you by Hubbard-Hall. Better results, less chemistry.
Well, today we're going to be discussing something I know it's near and dear to your heart is what you need to know when you're moving from solvent to aqueous cleaning. I know you've done a couple talks about this, but I really want to get into some real specifics about it. And is that a talk you enjoy giving?
Yeah, it's a good talk because one of the issues I think, and we deal with this on a regular basis as people call in and ask us to help them, is people that solvent degrease today and have never done water-based cleaning. They really believe that they're just going to call us up, say, hey, what cleaner do I need? And they're just going to start going and cleaning parts. When there are many other factors and variables that they have to think about or may not have thought about when they decide to make that transition. And so I feel like it's our job not just to try to sell people chemicals, but to make them understand that there are a lot of other things they're going to have to do to make that conversion. And honestly, if we can teach people that, it makes it easier for us to help make that conversion and eventually sell them a product or sell them a process. Don't really think about until we tell them and then they're like, oh, yeah, I hadn't thought about that. So trying to get the word out sooner than later.
Well, let's talk about that. I know there's lots of considerations. Let's talk about what you would consider as the number one, the top consideration when it comes to cleaning the parts that way.
I break it down into different parts of the process. You have chemistry, you have equipment, and then you have other issues like waste. And that's the three big categories. So we'll talk about chemistry first. So one of the benefits of solvent degreasing is that solvents tend to be universal for metals. In other words, it doesn't matter if I have a ferrous metal like carbon steel, or if I have copper or aluminum, or if it's whatever the alloy is. The solvents tend to be benign or inert to those particular metals, right? So I can run steel parts, I can run aluminum parts, so take for example, trichlor, TCE, standard degreasing solvent. I can clean all those metals in the very same trichlor bath without having to do any kind of changes or adjustments to the system, okay? When you get a water-based cleaning, these different alloys now, because we're introducing water and we're introducing different chemicals to make a cleaner bath, all these metals react differently to different chemistries. So now I may not be able to use a universal cleaner or a universal product to clean different alloys. Or I may have to set up a separate line to say run my aluminum parts versus running my steel parts. So it's a consideration that people realize that things are going to get a little more complex, because now we have to worry about the metals actually reacting with the chemicals we're putting in the tanks or the machine or whatever our cleaning equipment is. Whereas with solvents, we didn't really have to worry about that so much in the past.
Let's talk about part geometry. Everything's different, big, small, intricate, downholes, everything. Why is that one of the most difficult challenges?
Yeah, I have a prompt for that to show you. So part geometry is really important because, and I have an example of a part here. I don't know if we can see it, but this is a steel part. And you can see this part has a lot of small machined in areas. And if we were to get really close and look inside these recessed areas, there's actually more small holes inside of that. So if you're vapor degreasing or solvent degreasing, these parts sit in the vapor phase. The vapor penetrates all these areas, dissolve all the lubricants or soils out. The solvent then condenses, it pulls all those materials out. The surface tension of solvents is very low, so you get a clean, dry part. The geometry doesn't really impede the chemistry from removing the soil or removing itself from the part, okay?
Okay. Mm-hmm.
Right. As soon as I start aqueous cleaning these, I have two issues. Number one, I've got to have an aqueous chemistry that now I can get the surface tension low enough to get into these areas, but then I've got to get the chemistry out. And this is where rinsing becomes the most important part of the cleaning process. Because if I'm unable to rinse the cleaner out of all these blind areas, and then I'm unable to get the water that I use to rinse the parts out, I'm going to have problems with corrosion. I'm going to have problems with soil not being flushed out. And then over time, if I don't get the oils and things out of these small areas, I could get bleed out further down the process line. So in this example, these parts actually get plated. So they're going to go through a plating line. And if we're not able to rinse properly and flush all the stuff we cleaned out, that's going to bleed out into the other tanks. And that's going to cause problems down the process line. So again, it's a lot of physics and chemistry of solvent versus water. It's not an issue. We don't have to worry about these things like surface tension. We don't have to worry about rinsing per se, because the solvent's going to evaporate out of all these areas. Whereas with water, it's very difficult to get rinse water out of these type of parts. And if these parts happen to be steel, they're going to rust if I can't get the water out of all these areas and get them dried properly. So again, it comes down to simplicity of the process. Solvent is much simpler for tight geometries of parts, whereas water makes it much more complicated to get the parts flushed and dried properly. Somebody puts these parts in a vapor degreaser, the door closes, they get degreased, they come out, they're dry, they're ready to go. Whereas on an aqueous process, now you're going to need cleaner tanks, rinse tanks, and probably a heated drying process. So you've added two full steps and to the process that you didn't have to worry about before.
Right. And steps mean more complication.
More complication, that's more things that can go wrong. Rinsing and aqueous cleaning lines tends to be one of the most ignored steps. People let their rinse tanks get dirty. They don't flow enough water. They don't use the proper type of water. And so, you can clean the parts all day, but if you don't rinse them properly, you're never going to get actually good clean parts out of a water-based process if you don't have your rinses. So that whole introduction of being able to rinse and dry properly is an aspect of aqueous cleaning that someone that's only ever solvent degreased has got to learn to deal with.
Well, these are fixable problems, right? But you need to know what you're doing. You need to be aware of it, correct? They need to, had to be keenly aware that there could be a problem. And then, like you said, bringing someone like yourself or someone from Hubbard-Hall to kind of come in and based on, like I said, on the part geometry and everything else, you could put a formula together, a system together to really fix those problems that you spoke about.
Yeah, and one of the things I try to tell people is are there some chemistries that are better than others for some of these? Yes, but chemistry is not the whole solution to this problem of part geometry. That really equipment is a bigger part of the solution than it is the chemistry. So the type of cleaning equipment, what that process is, how parts are flushed, how they're dried. So equipment plays a much bigger role in part geometry and getting the right part clean and like you want it than chemistry. There's only so much we can do with the cleaning chemistries. The rest of it really does come to equipment itself and how does that equipment help you get to the final part that you need. So, unfortunately, we can't fix every problem with chemicals.
Let's talk about the soils that are on there. Some of them you can't see, or you just can't see. Some of them you possibly can see. So how does that work into factoring?
There's really two types of soils you're going to deal with generally. You have lubricants and coolants. and both of these can be used independently of each other, and sometimes people use lubricants and coolants. So kind of what's the difference, right? So a lubricant is really designed as to help, like say we're machining out these parts. It's part of the lubrication process to help cut properly, right? And those tend to be things like straight oils. They tend to be heavier. They tend to be highly hydrocarbon oil type materials. Then you have the coolants that are really designed to keep the tooling cool so the tooling doesn't overheat. Most people today are running, they use the term water-based, but they're not really so much water-based, they're water dispersible materials that they can incorporate them into water, and those help to keep the tooling cool. Those are easier to remove. So if someone's just using a water-based coolant to do their parts, those are much easier to remove. They don't leave a lot of residue behind. You can use very mild cleaners. They're easier to rinse off. It's a much easier process. But if somebody's using heavy oils to cut, then that's where we start getting into issues, especially in part geometry, if those heavy oils are down inside these parts. So then you need more aggressive cleaners. You need more aggressive rinsing. And then sometimes the parts will come in, if you're a job shop, the parts could be coming in with rust preventives already on them, and then those have to be removed. So, so really you got the two types of soils. You got the heavy, oily type materials and the coolants. And so like I tell people, coolants, generally not an issue. We can get those clean, but the heavier cutting fluids are more problematic for those type parts. And again, this is where solvents, when you run the solvent system, the solvent just universally dissolves off everything and you're good to go. So it's not a consideration you have to worry about when you're doing solvent cleaning.
And I'm sure it's always a good practice for these finishers to have good dialogue with their customers to know if anything's been changed, right? If any fluids have been added, changed, swapped out, or anything?
Yeah, if you're a job shop, I know I talk to a lot of times they don't know, though. They don't get informed. They tend to not know until they have a problem. We've had many customers over the years that will call and say, that we've run for, years and years and years, and I'll get a phone call and say, we can't get the parts clean anymore. And so the first thing I start asking is, well, what's changed? Well, nothing's changed. And then when you start doing some research and you start talking to them, you find out, oh, well, we found out this lubricant changed, or the supplier of the metal, of the actual part that they're making the parts, the supplier changed, and that supplier may be using some different soil or lubricant on the part. So, if you're a job shop, it's very difficult. If you're a captive shop, generally you're doing your own parts anyway. And so, I was just talking to someone not too long ago who told us straight out nothing had changed. And then somebody else came in the room and said, oh yeah, we changed one of the coolants in one of the processes, and nobody else in the room even knew that.
Their customers should be letting them know, right?
They should be, but sometimes they don't. Sometimes they honestly don't know. But that's our job. That's why we ask all the questions. That's why we always kind of press to try to get to, the
root cause.
Right, because we do this enough that if I'm told nothing else has changed, then we start looking at stuff that's coming in and maybe looking for changes there.
Well, great. Well, Mike, I appreciate this. Has been very interesting and eye-opening a little bit of all that it takes. We very much appreciate you sharing all that with us today.
Oh, anytime.
The Scene in South podcast is brought to you by Hubbard-Hall. For more podcasts, visit Hubbard-Hall.com or wherever you get your podcasts. Be sure to like and subscribe, rate and review, and join us on social media.